Solve the system. X squared plus y squared equals 49, and y equals negative x plus 7. So this x squared plus y squared equals 49 is a circle with a radius equal to 7, and y equals negative x plus 7 is simply a linear equation. So we want to find out the points of intersection. We're going to solve algebraically first using substitution here, because y equals negative x plus 7, we're going to substitute into the first equation for y, and then we will solve from there. So it will be x squared plus, and then instead of y squared, it's going to be negative x plus 7 squared equals 49. So then x squared plus, then we'll multiply out the middle part here. It's going to be negative x times negative x is positive x squared, and then negative x times 7 is minus 7x, and then 7 times negative x is another negative 7x, and then 7 times 7 is 49 equals 49. So we'll simplify this. X squared plus x squared is 2x squared, and then negative 7x minus 7x is minus 14x total, and then plus 49 equals 49. Well, we can subtract 49 from both sides and get 2x squared minus 14x equals 0. And this is going to be very easy to solve from here. We can factor out a 2x, and that leaves x minus 7 equals 0. Using the zero product property, we can say 2x equals 0 and x minus 7 equals 0. Divide by 2, x equals 0, and then add 7 to both sides, x equals 7. So we have two possible answers for x, and we need to substitute each one of those into one of the equations to find the y values. I'm going to use the line right here. It's a lot easier. So y equals, we'll use 0 first, negative 0 plus 7. That just means y equals 7. And then I'll use 7, y equals negative 7 plus 7, which is y equals 0. So our coordinates, we have 0, 7, and then 7, 0. And you can also use technology to graph these systems and solve by graphing. The difficulty is with a circle. See, a calculator doesn't want to graph a circle on a coordinate grid because it has a y squared, which means it's not a function. But what you can do is you can separate into two different pieces and graph that way. So in other words, I can take my x squared plus y squared equals 49 and then solve it for y. So subtract x squared first, I get y squared equals negative x squared plus 49. And then take the square root of both sides. Y equals plus or minus square root of negative x squared plus 49. So what you do is you make this y equals plus or minus into two separate equations. So you graph y equals the positive of the square root of negative x squared plus 49. And then you graph the negative, y equals negative square root of negative x squared plus 49. And these are two half circles. So if you graph them together, it will simulate the idea of graphing the circle x squared plus y squared equals 49. So let's take a look at that. So first I'll graph the positive, so it's going to be the square root of negative x squared plus 49. And notice that's all under the square root. Now let's just take a look at the graph of that one. Here I'm going to change my window. I'll go zoom standard, zoom 6. Okay, there we go. Now that kind of looks like a half circle or a half ellipse. If you want to make it look more circular, you can do zoom and then square, which is option 5. See, now it actually shows, instead of stretching, it's kind of like when you have a widescreen TV and then you have an older picture. The calculator was stretching it out because you have a wider screen than you do tall, but if you put zoom square, it changes the proportions back to normal. So now this half circle looks more like a half circle. And now let's graph the other part. That's going to be negative square root of negative x squared plus 49. Okay, so let's graph together. There you go. See, so this is like a simulated circle. Now all we need is the line. I'll put that for y3. It's negative x plus 7. So I'll go second calc, and then we're going to do intersection, which is 5. And then, see, it's already up there at the top, so just enter. And the second curve, we don't want that one. And we don't want that one. There we go. Finally got it on the line, and I just hit the up arrow or down arrow a couple times till I got on that line. Because we want the intersection of that top part of the curve and the line. Or it's negative 4.7 times 10 to the negative 14th, which is practically 0. So essentially it's 0.7 here, and that was one of our solutions. So I'm going to jump down to that curve on the bottom, and then now it's on that line. See, it says y3 equals negative x plus 7, which is what we want. Oh, it did find it. Okay, so 7, 0. There's the other intersection. Okay, so that does verify what we found using algebra. Okay, so we're able to verify these are the 2 points of intersection. So these are both solutions for the system.